Once again, good morning to one and all. Today we have discussed how to analyze the three-hinge arch. Of course, three-hinge arch is a determinate structure because of the third hinge. We know the bending moment at that hinge point is always zero, and that's why the number of unknowns are four and the equations are also four. That's why degree of static redundancy is zero. Okay, so let us solve this problem. Here, what is given? A three-hinge parabolic arch. Arch is parabolic, span is 20 meter and rise is 5. This height is 5. It is subjected to the point load 10 kilonewton acting at a distance of 5 meter from the support A. Draw the shear force diagram and bending moment diagram. Also determine radial shear, normal thrust under the point load. Okay, so in this problem, first of all, we can draw the free body diagram. Here, this is the example RA, HA, RB and HB. And when we apply summation Fx is equal to 0, there is only vertical load. That's why HA is equal to HB is equal to H. This is the equation number 1. Similarly, when we apply summation Fy is equal to 0, we get RA plus RB minus 10 is equal to 0, equation number 1. Then we can take the moment at point A, the HB multiplied by 0 because it passed from the same point. HA also passed from the same point and RA also passed from the same point. That's why moment of these three will be 0 and moment of RB, that is RB multiplied by 20 in anti-clockwise direction and 10 multiplied by 5 in clockwise direction is equal to 0, and in this way we get the value of RB, that is 2.5. And when we put RA plus RB is equal to 10, so we get the value of RA is equal to 7.5. This is the first stage. That means we can draw the free body diagram for arch, then apply the three equilibrium equation and find out the value of HA, HB, or we can say that H is equal to H, horizontal thrust, and RA and RB. Okay. Second part, we can break the arch from point C and consider either left portion in equilibrium or right portion in equilibrium to find out the, we can see that the horizontal thrust H, because H is at present unknown. We have just written HA is equal to HB is equal to H. Okay, and when we can take the moment at this point, considering this portion, can I say RB multiplied by this distance, that is 10 meter, and H, that is 5, which is unknown. H multiplied by this distance 5 is equal to 0, and from this RA is known to you, and we can take the moment at point C, we get the value of H, that is 5 kilonewton. Or we can consider this portion in equilibrium. Again, we can take the moment at C, RA multiplied by 10 and H multiplied by 5, and this is in the same direction, opposite direction, minus 10 multiplied by this distance. As this is 5, that's why this distance is also 5 is equal to 0, and from this we get the value of H. So this is the, we have just go through the calculation. This I can show the calculation here. This is the vertical reactions RA and RB, right? As I told you, RB is equal to 2.5, RA is equal to 7.5. Then consider any one portion, either left portion or right portion from the point C in equilibrium, and apply the moment equation, and we get the value of H is equal to 5 kilonewton. Okay, here AC we have considered in equilibrium. You can also consider the BC in equilibrium. We get the same answer, that is 5 kilonewton. Okay, then in the second part, once we can find out the support reaction, second part is related with the horizontal thrust, bending moment calculation and the horizontal thrust. Now in the bending moment calculation, first of all, as we know that the equation of the parabola y is equal to, this is very important, the equation of parabola is, that is the vertical distance is equal to, at a distance of x, what is the formula? 4h. H is the height, that is the rise of the arch. So 4h divided by total span, distance between the two supports, L square multiplied by L minus x. This is the formula to find out the y distance at a distance of x. Okay. So in the given problem, we can find out the radial and the we can say that the normal thrust and the radial shear. Okay, and that's why it is necessary to find out the y. Similarly, for the bending moment calculation, it is necessary to find out the y distance when x is equal to 5 meter. Okay, so y is equal to here uh, height is equal to rise is equal to 5, that's why 4 into 5 divided by span is 20 meters, so 20 square into L is equal to 20 minus x. This is the equation. So y is equal to 1 by 20 into 20 minus x. Okay, when I put x is equal to 5 meter, we get the value of y is equal to 15 divided by 20, right? So bending moment calculation. Now in bending moment calculation, this is the equation. When I have put x is equal to 5 meter, we get y is equal to 3.75 height. Okay. So moment at A is equal to 0, moment at D is equal to 7.5. That is the value of RB uh, multiplied by horizontal distance 5 minus 5, that is the horizontal thrust, multiplied by y distance, that is 3.75. So the moment at D is equal to 18.75. Okay, that is positive. That means the sign. So moment at C is equal to 0 again, because this there is a hinge at the crown. So moment at A is 0, moment at B is 0, moment at C is 0, and moment at D is equal to 18.75. As the load is point load, that's why the bending moment diagram. Before that, how to draw the bending moment diagram, that we will discuss in detail. See, say we have considered this is the arch, of course, maybe parabolic arch. This arch is the combination or superposition of the beam effect, beam, sorry, just a minute. Okay. So beam effect, that is the simply supported beam, span is same 20 meter and load is acting at 5 meter. So 20 kilonewton load is there, plus due to horizontal thrust. That means the vertical reaction and horizontal thrust over the beam, over the arch, not beam. So this is the combination of or superposition of the effect of vertical reaction and load, that is the beam effect, and effect of the horizontal thrust on the arch. Okay, so here we can I say the bending moment due to the horizontal thrust is equal to h multiplied by vertical distance, and vertical distance is related with the tracing of the parabola, and that's why the bending moment is similar to this parabola. H multiplied by 5, here h multiplied by 3.75, like that we get the, we have just traced the parabola, that is the bending moment due to the horizontal thrust effect, which is negative. And for the simply supported beam subjected to point load, it is triangular. Bending moment diagram is triangular, like this is the bending moment, that is the Ra multiplied by 5. So 37.50 kilonewton meter is the moment at this point. For example, for this example, and here it is say h is equal to say 8.33. This is just example. So 8.33 multiplied by this height, that is 3, we get 25. So the combined effect of this plus this, that gives the bending moment diagram for this given arch. So here it is observed that this is 37.50 at a distance of 5 meter. That means this triangle plus this parabola, that gives the bending moment diagram. And this portion is positive, this total portion is negative, that's why this will vanish, and this remaining will be negative. Left side positive, right side negative. Okay, so in this way we can draw the bending moment diagram for the given example. In our problem, this is the problem. So we have considered the bending moment, maximum bending moment Again, if I want maximum bending moment, this is the equation at a distance of x meter, 2.5 x minus 5 y. This is the moment at the given section at a distance of x meter, at a distance of we get the y. So this is the equation of parabola. This equation of parabola is uh, moment is equal to, so 2.5 multiplied by x and h multiplied by y in minus direction, that gives the moment. And this moment, to find out the maximum bending moment, we can take the derivative. So dmx by dx is equal to 0, so that we get the position of the moment where bending moment will be maximum. So x, so dmx by dx is equal to 0. So can I say 25, derivative of x is 1, that's why minus 25, and this is 5x into ey. Y is equal to, again we can put the y is equal to equation of parabola, and therefore we get 5 into 20 into x divided by 20. So the derivative of x is 1 and the derivative of x square is 2x. So 20 minus it is 2x. So is equal to 0. Here only one unknown is there, that is x. So we get the value of x. So x is equal to 5 meter from the support B. We get the maximum bending moment. But not necessary to find out this maximum bending moment, because in our problem only mention is draw the bending moment diagram. Okay. So which is again minus 6.25. When I put x is equal to 5 meter in this equation, we get the value of bending moment, that is hogging, minus 6.25. So this is the bending moment diagram. See the bending moment diagram. This is because of the point load. As I told you, Ra multiplied by 5, it is 18.75. This is the triangular, and due to horizontal thrust, it is negative. And this is the maximum negative bending moment uh, from the right side, that is 6.25. This is the bending moment diagram. So in exam we expect the bending moment diagram and this 18.75 or this net bending moment from the left side. Okay, this is the example. So in this way you can draw the bending moment. Similarly, shear force diagram, how to draw the shear force diagram? It is again simple. For shear force diagram I can just show here. Shear force diagram, definitely shear force diagram for horizontal thrust, this is horizontal and that's why there is no effect, but we have considered the shear force diagram for the beam, and we know that very well how to draw the shear force diagram for the beam. For this beam, can I trace like this? Horizontal line, reference line. Okay, then at A it is 0, at just right it is 7.5 positive, like this. Then up to point C it is constant, like this, and this is 10 kilonewton minus, that's why this is 7.5, right? So this is 2.5, total is 10. So 7.5 plus and minus 10, it is minus 2.5, again it is constant, and at B it is 2.5 positive, that's why 0. This is the minus, this is plus, this is the shear force diagram. Okay, so related to the only beam. So this is the shear force diagram. So there is no issue to find out the we can say that the shear force and bending moment diagram for the 3-hinge arch. So for the 2-hinge arch, many times the generally question may be asked, find out the horizontal thrust for the 2-hinge arch. And for 2-hinge arch, generally we have used direct equation, and the equation is h is equal to, with integration, m square m into y into dx divided by integration y square into dx. And when we use separately, we get the horizontal thrust. Above, of course, there is a integration involved. Just we can see the one example. Yes, this is the example. Find out the horizontal thrust for the here two hinge arch is there. H is the horizontal thrust and W is the load at the crown. But this is the example of two hinge arch. And for two hinge arch, we can apply the equation. This is the standard equation. H is equal to integration of m into y into dx divided by m is the bending moment at given section and y is the height, which is related with the, of course this is related with the parabola or the semicircular or circular arch. So in this problem, the problem is related with the parabolic arch. W is given at the crown at the top point and h is the rise and l is the span. So y is equal to 4h into x divided by l square into l minus x. This is the standard formula of the parabola. So first we have solved this m multiplied by y into dx. So what is m? M is equal to, here it is observed that load is at the center. That's why VA is equal to VB or RA is equal to RB is equal to W divided by 2 because it is distributed evenly, equally. So W by 2. So can I take the moment at certain distance? For example, here we have considered, say this is the section, this distance is x, this distance is y. What is the moment? Can I say VA multiplied by x? So VA is equal to W by 2 into x. That's why the moment is equal to W by 2 multiplied by x. Okay. So this is related with the moment due to the beam effect, not the horizontal thrust. Okay. So m multiplied by y, m is equal to W by 2 into x and y is equal to, this is the equation of the parabola in terms of x and h. So I have put here. And what is the limit? The limit of this x is equal to 0 to L by 2, this point. Okay. Again, here it is observed that load is at the center and when we have taken the section from this side, again we get the same equation. That is this one. And that's why we have considered A to C and B to C and apply 2, that is double, because whatever the section taken from this side, we get the same equation from this side, same equation. That's why this is double and the limit is 0 to L by 2. So solve this equation, W by 2 into x into y, that is the 4hx divided by L square into L minus x. Solve this and after solving this we get the m into y dx, that is the numerator. Okay. So here, sorry. Hmm. So here we can find out the, just a minute. We can find out the numerator, that is the integration of m multiplied by y. Similarly, we can find out integration of y square into dx. Y is known to you. Square of this, that is 4hx L square in bracket L minus x whole square. Solve this, integrate and find out the this value. So here integration of y square dx is equal to, yes, this is the integration of m into y, that is 5 by 48 w h into L square, and integration of y square dx is equal to, again here why we have considered 0 to L, because y is related with the x, and here the value of x is equal to 0, that is at support A, and x is equal to L, it is at support B, and therefore it is 0 to L, 0 to L instead of 0 to L by 2. Okay, so we get the y square dx with integration is 5 h square L divided by 15, and put this value in the equation. H is equal to integration of my into dx divided by integration of y square dx, we get the 25 WL divided by 128 H. These are the standard value. And generally in examination, either point load or UDL acting throughout the span is it generally asked in the examination. So best of luck. Thank you. Thank you very much. Have a nice day.